All right, so we talked about molar mass. Molar mass, which is the mass in grams of 1 mole. So like I said, one of the few things in science class that were actually named kind of nicely. So molar mass, we're going to use that to convert between the mass and the moles. Or the moles and the mass. So I'm going to show you guys the fancy equations we're going to build into. Let's say you're searching for the mass in grams, but you're starting with number of moles. We're going to be able to set up conversion factors where we're going to want to cancel out the number of moles and get to grams. So how we use that is molar mass. So we are going to put our mass in grams per 1 mole. So this whole species here, this is what we know as molar mass. Because what you guys are used to seeing is I write it as G/MOL. It's the same thing to put G over 1 MOL. We just typically have some sort of number representing our grams. So this is just different ways to write molar mass. Any questions on that? Like I said, it might be a little weird at first. When we start doing practice problems, hopefully it'll start to make sense where all these parts are coming from. Now, other way around, let's say you want to get to moles and you start with some sort of mass in grams. Instead of multiplying by our molar mass, we're going to put our mass term, our grams, on the bottom of the conversion factor. So we're going to have our mass in grams per 1 mole. So again, this still here, or this here, is still your molar mass. It's just upside down. So we're kind of going to have to really reach back to unit 3, thinking about what it means to have a numerator and denominator and when things start to cancel. Like I said, I'm just going to kind of introduce this to you here. We're going to go through some thinking problems where we don't even have to do conversions yet. And then we're going to hit the conversions hard. Any questions on these couple formulas here? Okay. So how do we find the mass of 1 mole of something? Exactly, grams per mole. So we're going to calculate the molar mass or the mass of 1 mole of methane. So what is the mass of one carbon? Well, we have 112 gram per mole carbon. Hydrogen, how many do we have for here though? We have 4. So 4 times the mass, which is 1. So we will get 4.0 and 12.0 from carbon. And so our last step here is to what? Exactly. We add these together. So our molar mass of CH4 is equal to 16. All right, how are you feeling about calculating molar mass? Is this something that you guys are starting to remember, get down a little bit? Feeling okay about it? Sweet. All right. And now let's see if anyone remembers this. That blank spot is for the specific representative particle. So methane, CH4, is that a formula unit or a molecule? I think I heard it. Molecule. Yeah. So molecules go with covalent or non-metal bonds. Formula units go with ionic or metal-non-metal. So this is a molecule because both carbon and hydrogen are non-metals. So how many molecules are in 1 mole? Beautiful, 6.02 times 10 to the 23rd. You guys, like I said, should get sick of that number. That's how many molecules per 1 mole. Now, if I have half a mole of methane, what would my mass be? So that's how many molecules. Now we're talking about mass. So this term here, this is defined as 1 mole of methane weighs 16 grams. So what if I have half a mole? Bam, 8 grams. Beautiful. Because this is just 0.5 of 16. Now, so technically it's just grams because this 0.5 has units of moles. And if you multiplied them, moles would cancel out. But I don't want you guys to worry about units quite yet, but I love it. Love that's where your mind's going. Okay, how many molecules in half then? I think JP, you're on to this one already.
Yeah.
You got it, exactly. So if we just took half, so this is the number, this is how many molecules per mole. If we have half mole, we just half that number. So you can just half the coefficient. We would get 3.01 times 10 to the 23rd molecules. So this is just, nope. Now, how much will 2 moles of methane weigh? Oh, you guys are brilliant. So this is just times 2. So this all has to do with the fact that molar mass is defined as the mass per 1 mole. If we have 2 moles, it must weigh twice as much. How many molecules will be in twice as much? Beautiful. 12.04 times 10 to the 23rd molecules. Now, before you flip the page. So, is this proper scientific notation? No, technically the more correct way would be if we move this decimal 1 spot and then we need to raise the power of 10 by 1. So I just want to make you guys aware that this number is the same thing as 1.204 times 10 to the 24th. So you might see either. I will accept both as valid answers, but I just wanted to make you aware of this relationship. Any questions on what we just did? All right, now is your opportunity to try these out on your own. So now you're going to do the same idea, except with sodium hydroxide. What did you guys get for the mass of 1 mole of NaOH? Beautiful. Okay, so to figure out the mass of 1 mole, we're calculating the molar mass. We have 1 sodium, 1 oxygen, 1 hydrogen. So I'm filling in their masses from the periodic table. We add these up, you should get 40 grams per mole. So was there any question on how to calculate molar mass? Or we feeling pretty good about molar mass? We like that. Okay. Now, sodium hydroxide, NaOH. What type of element is Na? It's a metal. What about hydroxide? Beautiful. Metal plus non-metal means ionic, which means formula units. Now, all this is the fancier term for particle. We're still talking about the Avogadro's number of things. Instead of calling it a particle, we're just getting more specific and calling it a formula unit. Just like you might call someone's lab a dog, but if you want to get more specific, you call it a lab. We call these particles, but to get more specific, we're going to call it formula units. Now, how many particles, formula units, atoms, molecules do we always have in 1 mole? Awesome. So we have 6.02 times 10 to the 23rd. I'm going to abbreviate form units in 1 mole. Okay. Now, molar mass is literally defined as the mass per 1 mole. What if we have 0.25 of a mole? 10 grams. We just take 0.25 of our molar mass. So 0.25 of 40 gives us 10 grams. What if we have 0.25 moles? How many molecule formula units would we have? Yes, we would have 0.25 formula units then, which equals 1.505 times 10 to the 23rd formula units. Yeah. What? Not these ones. So to be honest, the one I care more about you guys rounding is molar mass. It just make it easier on yourself, round to a 10th. When it comes to significant figures, don't worry about that for this unit. I care about more on, can you guys do this versus sig figs, okay? So don't worry about sig figs for this unit. Number 5. So for this one, you have to recognize that this 1.2 times 10 to the 24th is the same thing as 12 times 10 to the 23rd. How does this number relate to our definition of how many formula units are in a mole? It's twice as much. So that means we must have 2 moles. Now, number 6 was a little more complicated. It's more of a 2-step process. So we need to figure out how many formula units are in 20 grams of sodium hydroxide. I will let you know, you are going to be sick of moles. Moles are at the center of everything. We don't even talk about moles here, which means probably not to do 2 steps. So thinking about the mass we have 20 grams. How does that relate to the molar mass? It's half as much. So that means we have half a mole if we only have 20 grams. So 20 grams is 0.5 of 40 grams per mole. So we're working with half a mole. How many formula units are in half a mole? Exactly. 3.01 times 10 to the 23rd. All right, any questions about this before we dive in a little deeper? Okay, so now what I'm going to do is I'm going to give you guys a visual map of kind of how I want you to approach these problems. So I'm a visual person, so here's my example for you. What is at the center of this? So moles. When in doubt, convert to moles. So we're going to break it down first at the relationship between particles and moles. That means if you see any of these, it's the same thing as a particle. What number do we use between moles and particles? 6.02 times 10 to the 23rd. Now it depends how we're going to use it. Depends what direction we're going. If we start with the number of particles but want to find out how many moles, we are going to divide by 6.02 times 10 to the 23rd. So that's for the left arrow. If we want to go from moles to particles, then we multiply by 6.02 times 10 to the 23rd. So these revolve around Avogadro's number. And I will abbreviate that as AN sometimes, just so you guys are aware. All right. Now, we're going to zoom in now on moles and mass. Moles and mass. If you say that quickly, what does it kind of sound like? Moles and mass. Molar mass, right? So going between moles and mass, we're going to use our molar mass. So leftmost arrow, we are going to multiply by molar mass. So if we start with moles and we want to figure out our mass, we multiply. If we start with the mass, want to go to moles, we divide by molar mass. Now the other one that's under construction, we will talk about that at a later time. It has to do with volume, but we won't worry about that for today. Any questions on kind of the little roadmap we just drew out here? What I expect is you guys to use this kind of like a crutch until you get super good at conversions and don't need this anymore. One thing I will say too, going into this next part of lecture, I will teach how to do conversions probably like multiple different ways as we go through them. So I'm not going to teach it the same way every problem in hopes that one of the ways will click with you, because there are multiple ways to think about these problems. So what I wanted to talk through, now that example that I gave you, we just talked about how many formula units are in 20 grams of sodium hydroxide. We kind of just reasoned through that, but I want to show you the math that actually goes with it. So instead of saying how many formula units are in this, yada, yada, I'll just tell you guys to do a conversion. Convert 20 grams to formula units. Well, do either of these have mole? Are either of these units a mole? Nope, we have grams and formula units. So that means we are going to have to convert to moles and then to formula units. So if we were to look at this map, we are going from a mass, converting to moles, and then converting to formula units or particles. So this is the roadmap that we're going to take for this one. Now, reaching back to chapter 3, we always start with what we know. Well, what quantity are we given? Grams. We're given, we know we have 20 grams of sodium hydroxide. Now, we are going to use conversion factors. So how do you go from grams to moles? You divide by the molar mass, right? Dividing by the molar mass means we had to calculate it, but you guys already did. What did we say the molar mass of sodium hydroxide was? So the molar mass is equal to 40.0. Remember, grams divided by 1 mole. So when we say we divide it by our molar mass, that means the number that is a quantity. So whatever goes with grams will go on the bottom. We're dividing by that. So dividing by molar mass means we're dividing by 40. And then that means we have our 1 mole left over. So in reality, we are flipping that conversion factor. So when I say divide by molar mass, yep. So good question. When we're doing these problems, to think about what is the numerator, what is the denominator, it is important because if you're multiplying two things and the unit is in the numerator of the one and denominator of the other, they cross out. So it's important to remember that underneath this 20 grams of NaOH is an imaginary 1. So the 20 grams is in the numerator. Knowing that, the grams here will now cancel out with the grams at the bottom. So we're only halfway done with the problem. What we've done right now is at this point. Now we have to do the conversion between moles and formula units. So we're going to set up another conversion factor. How do we go between moles and formula units? We're multiplying by Avogadro's number. So remember how we define Avogadro's number. If we're multiplying it, it gets the 6.02 times 10 to the 23rd formula units in 1 mole. Now, the moles from the molar mass cancel out with the moles from Avogadro's number, and we are left with our target unit of formula units. So if you multiply this out, you'll get the same thing that we did get for 6, but I wanted to show you the math behind it. So this was an example of a 2-step problem. So what I want to point out on the thing below here is it says, if one of the two units you're converting between is not moles, then you're going to do a two-step problem. We always have to convert to moles before we move on. So what we're going to do, let's do a few where we actually have moles. So there'll just be one step, and then we're going to build our way back into a two-step problem of one we haven't seen before. So we're going to start off with this first one here. It's asking us to convert between grams of H2 to moles. So luckily, one of our units are moles. That means it's going to be a one-step problem. Now, I'll give you a hint. Anytime you see units of grams, that means we need to find the molar mass. Okay, so we are finding the molar mass of H2. Molar mass of H2, what does that equal to? 2, because you get 2 times 1.0, which equals 2.0 grams per 1 mole. Okay. So what I always say, start with what you know. What do we know? How many grams do we have? 5. We have 5 grams. So we start with that 5 grams. We know we have that much of H2. Now, recalling that this is over our imaginary 1, there's a couple things, ways to think about this. One, we want our grams to cancel. If we want our grams to cancel, do we want grams on the top or bottom of our conversion factor? On the bottom. So are we going to keep this the same or flip it? Flip it. So we're going to put the 2 grams on the bottom per 1 mole. Do we need to do anything else? Nope. Now we just calculate this. 5 grams divided by 2 grams equals 2.5. And now we have units of moles because our grams from the 5 cancel out with grams from our molar mass. So if you think about this, this would be a dividing by molar mass. Yes, we are multiplying by a conversion factor, but the larger numerical value is what is on the bottom, therefore doing the dividing. So this step, number 1, going from grams to moles, is the same thing as dividing by the molar mass. Now, another way I want you guys to think about it, if you have trouble deciding which way to put your conversion factor, what I say to myself is target on top. What is your target unit for number 1? Moles. Put the target unit on the top of the fraction. We put moles on top, therefore grams goes on the bottom. This is another way to think about it. So number 2, we have grams again. So what are we gonna have to calculate? What does grams mean we have to find? Molar mass. So we're finding the molar mass of water. If we do that, we have 2 hydrogens, 1 oxygen. We add those together, we get 18.0 grams per 1 mole. Now, we'll have to use that, but we're going to start with what we know. Well, we know we have 636 moles of H2O. Using our conversion factor of molar mass, are we going to use as is or flip it? Keep it the same. Because what's our target unit? Our target is grams, put the target on top. We're going to keep the grams on top of the fraction. So we have 18 grams per 1 mole. This allows moles to be canceled out. We're in units of grams, which we want. So if we take 18 times 636, I forget it off. I forgot to write it down. It's like 11,400 something. 448. Okay. So this is how much water we have. Any questions about this one? So these first 2, this is working with the molar mass. So anytime you see grams in a problem, you're gonna have to use the molar mass. Yeah.
Not really understanding, no, when you flip it and when you keep it the same.
So it all has to do with the units you want to cancel out. So for the first one here, we know we want to get to moles. We're starting with grams. And so in order to get from grams to moles, we have to use our molar mass because it has both of those units. Now we start with grams. In order to cancel out, our grams has to also be on the bottom because whatever's on the top in the numerator will cancel out what's in the denominator. So the reason why we have to flip this is because if we just multiplied it here, you would get grams on the top and moles on the bottom and end up getting grams squared, which is bad. So we have to put grams on the bottom of the fraction so that this one cancels out with our initial grams here.
Okay, yeah, that makes sense.
And then the next one here, we're starting with moles. So in order to get this moles to cancel, which is really over an imaginary one, is we have to make sure that our mole part of our molar mass is on the bottom. So this one cancels with this one.
Yeah, that makes sense.
Okay, all right. Any other questions? Yeah, go ahead, Axel. Yes, because it's technically grams of water. So like, I'm not going to be super picky. It's going to be helpful to label things when we do what is called stoichiometry and you're actually converting between two different compounds. But for now, I'm not going to be too picky about having H2O there. Yep. Any other questions? Okay, so this is using molar mass. So according to your math, if you are multiplying by molar mass, this is the same thing as multiplying by your number of grams over 1 mole. If you're dividing by your molar mass, that is when you flip your conversion and have 1 mole over your number of grams. Does that kind of help make that connection there of what I mean by these things? Okay, so the next two problems, they have to do with particles. So we're going to be using Avogadro's number. So number 3, when you see things like molecules, that means we are going to use Avogadro's number, which we'll call, in our case, I'm just going to use molecules. That means we have 6.02 times 10 to the 23rd molecules in 1 mole. So to convert, we start with what we know. Well, we know we have 7.8 times 10 to the 20 molecules. And we want to go to moles. So if we look at our map, we start with the number of particles and want to go to moles. So what are we doing? Dividing by 6.02 times 10 to the 23rd. That is where we put that term then, is on the bottom. We want to divide by that. So 6.02 times 10 to the 23rd molecules. So we're dividing by that number per mole. So pretending we have our imaginary 1, that allows molecules from our initial number to get canceled out with molecules from our conversion factor. We're left in units of moles. If you put this in your calculator, you should get, I think this one was 0.0013. Don't calculate that out. So moles. What's up? Is that what you're wondering, Rashad? Was it? No, I'm just trying to understand a question. The molar mass, is that what you're wondering about? So since we don't even touch grams here, we don't even have to worry about the molar mass. So where we're at in our little map. So down here, if we're talking about mass, yes, this is where we focus on molar mass. But really, we're only focusing on this portion here, which only has to do with Avogadro's number. So not every single time you'll use it, but good question. Okay. All right, let's do the next one. So again, we have our molecules term, which means Avogadro's number. Here though, we start with 548 moles of SO2. So we have to decide, are we going to use this factor as is or flip it? Keep it as is. So we have 6.02 times 10 to the 23rd molecules in 1 mole. So now our moles from our initial number cancel out with our moles from our conversion factor. Our target unit of molecules is at the top of our fraction. So target on top, great. If we multiply this out, we get, I think it's 3.3. Does anyone do this one yet? Times 10 to the 20. Yeah, I was gonna say, I think it's higher. 26 sounds right. Molecules. Sorry, I forgot to write down these answers. I've done them like 3 times today already. What a joke. Just kidding. What's up? Any questions about these two that we just did? So these two have to do with Avogadro's number. Any questions before we move on to the 2-step process? Okay, so what we've just done, so 1 and 2 focused on this part of the map. 3 and 4 focused on this part. 5 and 6 are going to involve this whole entire thing now. So really what we're going to do is 1 step here and a 2nd step here. Maybe our 1st step is this way and then a 2nd, but we are going to start doing some 2-step problems. So if you notice for number 5, there's nowhere in the units, doesn't mention moles. So that means we have to go moles in between. So how I like to draw these maps out is we're starting with molecules. We always have to go to moles. And then we're going to our final unit of grams. How do we go between molecules and moles? Avogadro's number. So this is going to be one of the steps. Our 2nd step is going from moles to grams. What do we use here? Molar mass. So these are going to be our 2 little fractions we're going to set up. So starting with, I always like to calculate molar mass to get that out of the way. I realize I never gave you what this was supposed to be of. This is supposed to be of SO2. So I'm sorry. So you guys want to write in of SO2 here. We need that to figure out molar mass. So if we figure out molar mass of SO2, I'm not going to go through it because you guys should know by now. You would get 64.1 grams per mole. All right, so got that out of the way. We're going to need that tool. Let's start with what we know. Well, we have 9.6 times 10 to the 25th molecules. What is the unit that we want to get to first? Moles. Moles is our target. We're going to put moles on top. How do we relate molecules and moles? Avogadro's number. So if we start with molecules, want to get to moles, we divide by Avogadro's number. That's how many molecules are in 1 mole. So this step here, I'm going to change colors here for a second. This is like doing route number 1 on our map here. Now we're going to set up our second conversion where we are going from moles is where we're at, and we want to go to grams using the molar mass. So if we stop and look at what we're working with, we canceled out molecules here with this one. We're in units of moles. Where do we want to put moles in the next fraction to cancel it out? On the bottom. And what is our target unit? Grams. So grams we want on top. This is, what do we know that relates grams to moles? Molar mass. We already figured that out. So we know that there are 64.1 grams per 1 mole. I'm just getting that from the molar mass of SO2. You multiply this out. I don't remember off the top of my head either. 1 second. Oh, I should just go up. I already had it up here. It would be, it's this one. That's not right. 1 sec. Sorry, guys. One thing I will say, one of the hardest parts about these problems is making sure you type them into your calculators correctly. And so my biggest hint for you is when you're typing in scientific notation to put parentheses around the whole term. I'll show you what I mean here in a second. All right. Oh yeah, what's this one? So I got 10,222 grams of SO2. So like if I was typing this into my calculator, I put parentheses around the outside of this coefficient and here. So parentheses, and then I do divide, parentheses, times, and then 64.1. So make sure that you're putting parentheses around these outer terms here. It'll just help. Otherwise, you'll start getting crazy stuff. All right, last one here. We have grams, so we need molar mass. And so if we calculate the molar mass with potassium chloride, there's 1 potassium plus 1 chlorine, we get 74.6 grams in 1 mole. We also are working with formula units, which means we need Avogadro's number. We've already recognized we don't have moles, so we are going to have to go to those first. And so I'm going to write over here kind of my map here. We're starting with grams. We know we want formula units. We always have to go to moles first. This is my map of how I'm going to solve these problems. So how do you go between grams and moles? We use what? Molar mass. How do you go between moles and formula units? Avogadro's number. So those are our 2 conversions we're going to have to do. So 1 and 2. Start with what we know. Well, we have 0.025 grams of KCl. We're going to have to use our molar mass, which we have defined up here. Do we multiply by this as is, or do we want to swap what goes on the top and bottom? Flip it. So we have 1 mole. There are 74.6 grams. And so we flip it so we can cancel the grams here with the grams here. We're left in units of moles. Great. We just did step 1. Now we're going to do step 2, converting from moles to formula units. So we're going to use Avogadro's number. Do we want the big 6.02 blah, blah, blah formula units on top or bottom? On the top, that's our target. We want 6.02 times 10 to the 23rd formula units for 1 mole. Yeah. Yeah, so the first box that I drew was step 1. This one here would be the second conversion. So this would be the second step. Yes. Yep. 2.0 times 10 to the 20th formula units. All right, so these last two were two-step problems. I want to ask you guys a question here. So for number 3 here, we're asked to convert 7.8 times 10 to the 20th to moles. How many molecules are in 1 mole? Is this more or less than that? Less. So 10 to the 20th is less than 10 to the 23rd. So if we have less than what's defined as a mole, do you think that we should get less than a mole as our answer? So that's another way to think about it if you did something wrong. If you get a number of moles that has powers of 10s, you did flip your ratio. Something's wrong. So I just want you to start recognizing what actually makes sense depending on our definitions. Like here, if 1 mole is 6.02 times 10 to the 23rd, and we have 548, we better have more than this many molecules or else you did something wrong. So I just kind of want to get you guys start thinking about that.